Hey guys, welcome, and in this video series we will be talking about alternating current in grade 12 and also for your joint or Neet exams it will help you. So I'm gonna talk about alternating current in different sections, and this is section 1. So first, we know what a current is, right? I'm assuming that you have a basic idea of current. You can write it as Q upon T. Even you know the derivative dq dt. You have some basic idea of calculus, and so these are the prerequisite before taking this course. You have to have some knowledge about calculus. You have to know how to draw graphs, aka coordinate geometry. You need to have some idea about that. You need to have some idea about trig. So if you have taken trig classes, trigonometry, then it will help you. So you need to make sure you know calculus, you know graph, coordinate geometry, you know trigonometry, and you have some idea about current. Like you have basic grade 10 idea of what a current is, and it's all the equations, Ohm's law, and even some of the electrostatic things. If you know them, you're gonna get ahead in this course. Alright, so without further ado, let's see current. So we know what a current is. Conventional current, we know that the voltage source, it's a basic source of current, and current flows from the positive terminal to the negative terminal. And conventional current is the current that its direction is basically opposite to the direction of electrons. So if we have a lot of negative here, a lot of positive here, conventionally we say electron is flowing from negative to positive. And that makes sense because there's a lot of negative here and there's a deficiency of negative charges. So negative charge, aka electron, will flow from here to there. And conventional current is the opposite direction to this flow of electron. Now you might ask me, why is that so? Oh, the wind is currently flowing me off. Pardon me for that. But it's the convention. So that's basically what current is. But there are two types of currents you might have heard of: a DC current and AC current. In this course, we'll talk about AC current. But what is the DC current? DC current is basically a direct current. What is a direct current? It basically electrochemical cell. That's the primary source of this direct current. It cannot change its direction. It flows only in one direction. You can compare it to, for instance, let's say if you have a hose pipe and water is flowing through it. Water cannot flow in two directions. So water can only flow in one direction. Okay? So just like a hose pipe, you can think of the DC current flowing in one direction. So basically, if we have a resistor here and it is connected across the terminals of a battery, so a positive 5-volt battery, you can think of it. It's the positive terminal, the negative terminal. I hope you can draw the batteries. This longer one is the positive, the shorter one is the negative. So if we do that, then a current is established in this circuit. The current has a unique direction. It goes from the positive terminal to the negative terminal, like this. We know that, right, by convention, via this external resistor. This is a resistor with some resistance R, let's say. Now the magnitude of this current is also remains almost constant. You can determine it through V equals IR. If you use this formula, you can get this current. Pardon the quality for a sec there, but this is how you can calculate the current. The voltage is equal to current times resistance. But this is all about the DC current. But what AC current is, it's completely different from this. If the direction of the current in a resistor or in any other element changes alternately, the current is called an alternating current. So the direction, so alternating current is the direction. Suppose the current is flowing in this direction in one moment, and then after 2 seconds it's flowing in that direction, and after another 2 seconds it's again flowing in that direction. So alternate current or AC current, it's basically the current AC alternately, mainly there's a time interval, alternately changes direction. Alternately changes direction. So that's what our AC current is. it alternately changes direction, and the wind is changing my direction here, so pardon me for that. It's a pretty strong wind out there, but anyway, so that's about this alternating current here. Now in this chapter, or in this section, we will go over the alternating current in various sinusoidally with time. So like I said, the interval is going to be a time interval, time dependent. So alternating current will vary sinusoidally with time, right? So how can we say that? So again, sinusoidal meaning that in an equation where you heard sinusoidally, you would automatically think of it depends, like there's a sine or cosine term. So I is equal to I naught sine omega t plus phi. So this is an equation of current. So this is my AC current. This is the value at some initial time, and this is how it depends on how it varies sinusoidally. Sine omega t plus phi. This is the equation that will help us here. Okay. So, and if you draw a graph, it would look like this. You can plot a graph between I versus time t, and it would be like this. So this is a sine curve, like sine starts from here literally, but that's just if you draw a sine curve like this, it depends where you place it. So if you place the origin here, that's the sine curves like this. If you place it over here, then it's a cosine curve, basically starts like that. Or here they placed it here, here this is how it started, like this. So basically, when you hear the term sinusoidally, you basically know that it depends on sine and cosine, or its nature is like sine curve or cosine curve. So my take home here is that the alternate current we will talk about in sinusoidal form. Like if this is my AC current, this varies sinusoidally like this. Phi is the phase, omega is the frequency, all these things. Okay, so the current repeats its value after each time interval. T is equal to 2 pi upon omega. This is the time interval you've been talking about since lower classes. T equals 2 pi by omega. And this time interval is called the time period, as usual. The current is positive for half the time period and is negative for the remaining half period. So within this time period, so if this is the total T time period, let's say, and for the half it's positive and for the half it's negative. So again, we are getting into positive current and negative current. For a DC current, we never talk about a positive current because that's a conventional DC current, flows from positive to negative. But when we talk about AC current, we talk about positive current and negative current. So that's the concept we come across here. This means that its direction reverses after each half time period. So in a time period, half the time period is positive, half the time period is negative. So its direction reverses each half period, each half time period. The maximum value of the current is I0, which is called the peak current. So I0, this is the peak current. Peak current, this is the maximum value of the current. It is also known as the current amplitude. To get sinusoidally varying alternating current, we need a source which can generate sinusoidally varying electromotive force, EMF. So I hope you know what a generator is, a dynamo is, these things. So we need basically an AC generator, also called an AC dynamo, that can be used as such a source, which can give us a sinusoidally varying EMF. So if we have a sinusoidally varying EMF, and again sinusoidally meaning sine curve, it varies, it follows this equation. It's kind of hard to understand physically, but mathematically sinusoidal is basically a sine curve when you draw it on paper. I know physically when you're doing it practically, it's kind of hard to grasp this concept, like how can I produce sinusoidally, but so far theoretically just think of this. So we know dynamo converts mechanical energy into electrical energy, producing an alternating EMF. So we will go over this AC generator or AC dynamo concept if you don't know it. How does it work and what is that? And then we'll go to some household power generation, what we use at house, and instantaneous and RMS current. All those topics in alternating current we'll cover. But this is just basic idea of what we're going to cover in this course I've gave you. And also we're going to look into a lot of circuits, simple AC circuits. So you need to have an idea of what is an inductor is, resistor is, capacitor is, and we will take a look at impedance. We have called resistance so far. Now we'll take a look at that. We'll look at different coils. We'll look at different motors, and we'll also even cover DC dynamo. And then we'll take a look at some easy examples and some homework problems. Alright, so this is the introduction to alternating current. I hope you enjoy it, and if you have any doubts, questions, comment below. I'll cover all the parts later.